Hi everyone, welcome to my channel. My name is Dr. Selena Vasquez Mireles. This video is part of the Geometry Star Review series. Let's get started. Okay everybody, this is Geometry Star Review Week 1, Triangles. Remember, we're going to do the subject, terminology, assessment, and relevance. So let's talk about triangles. All right, there are a lot of different kinds of triangles. Perhaps the first word that comes to your mind is the idea of Pythagorean Theorem. And Pythagorean Theorem, that is relevant to the idea of a right triangle. So we're particularly going to look at a right triangle. And here's a picture. Usually we see that little square. This side is called the hypotenuse. This is a side, and this is a side. And later in trigonometry, we'll refer to the side relevant to each of these angles. So this angle in here, this is an interior angle, this is an interior angle, and we would say this side is opposite of that angle. That comes later, but it's really good to understand the language right now. So the right triangle, this means that it has a 90-degree angle. And like I mentioned just a minute ago, we're talking about Pythagorean Theorem. Pythagoras was old mathematician who in many years ago, when that's what I meant by old, many years ago, he was part of a secret society that studied mathematics, and he is given the credit for the Pythagorean Theorem. And basically the Pythagorean Theorem says that if you have, and I'm going to call this side out for, just for clarity, I'm going to call this side A, this side B, and this side C for the hypotenuse. Okay, the Pythagorean Theorem says that if you know that the relationship of the sides a squared plus b squared equals c squared, that is true if and only if, and I'm going to use these double arrows. It's a good idea to understand your logic when you're talking about geometry. Sometimes you'll see that as IFF. It's not a typo, it's meaning if and only if. And I'm going to go ahead and write the words if and only if. That means that in logic terms, it can go this way, this one implies this one, and this also implies the other way around. So a squared plus b squared is c squared if and only if, and I'm going to call this, I'm going to go ahead and use a different color. So I'll call this side, or this vertex A, this one B, and this one C. So this is true if and only if triangle, that's the symbol we use for triangle when we're using geometry. Remember, we use a lot of notation. So it's if and only if triangle A, B, C is a right triangle. So this is really important because since it can go both ways, this is saying that triangle ABC, if you know that it's a right triangle, then this relationship of the sides must be true. This is also saying that if you find that the relationship of the sides is such that a squared plus b squared equals c squared, then triangle ABC must be a right triangle. So it's a very powerful theorem, Pythagorean Theorem. Okay, and this is also related to the triangle inequality theorem, which I want to just touch on briefly. So there's Pythagorean Theorem, but there's also the triangle inequality. Actually, let me go ahead and write it down here. and you're probably going to get this in class too. So this is saying that the relationship of the sides, not necessarily a right triangle, like in this case, but any triangle. Any triangle. This has to be true. So let me write it in here so you can see what I'm about to say. That A plus B has to be greater than C. B plus C has to be greater than A. And A plus C has to be greater than B. These things must be true in order for this to be a triangle. Okay, so now let's go on to terminology. I wanted to just bring that to your attention about triangles and what that comes from. And, notice the word tri, that means 3. An angle, well, we should know what that means too. So there's 3 angles. That's what where the terminology, the word triangle comes from. You also want to make note of the fact that there are different kinds of triangles. Like I mentioned earlier, so you have obtuse, acute, you have the right triangle, like we talked about a minute ago. You have a scaling, isosceles, equilateral, also known as equiangular. So these are different kinds of triangles that we will see and have different properties that are important. So I wanted to make sure that you saw those triangles, those types of triangles sometime before you actually get into them more, that you see the words. Okay, then the next thing is assessment. So common, you'll definitely see this on standardized exams. Pythagorean Theorem is extremely important. You'll see this SAT, ACT, you'll see these in your subject exams, you'll see this in your standardized exams, even just identifying a right triangle. So let's look at a problem. So suppose you have a triangle. So you're given triangle X, Y, Z, and it looks like this. And I'm going to go ahead and tell you it's a right triangle. And I know that this side is 3 meters, this one's 4 meters, and I'm asking you to find this side right here. Okay? So since it's a right triangle, then I can invoke Pythagorean Theorem. So I can say, and I like to write it down, Pythagorean Theorem, but I use some shortcuts in my writing, as you can tell already if you've been following my videos. So then, since it's a right triangle, I can use Pythagorean Theorem, and I know that a squared plus b squared equals c squared. So write the formula down. So I have 3 meters squared plus 4 meters squared is equal to this value squared. So 3 meters squared, that is 9 meters squared plus 16 meters squared equals to the value that I'm looking for, c squared, and 9 plus 16 is, so I can combine my terms. I have 25 meters squared equals to c squared. And since I'm the person taking the square root, that's an important thing, then I'm going to have plus or minus, but the only thing that makes sense for distance is positive. So I'm going to have the square root on both sides. I'm the one who's taking the square root, so I have c equal to plus or minus 5 meters, but I can't worry about the negative because I'm talking about a distance, so only the positive value works. And so my result is that the hypotenuse, which is the value that's missing is 5 meters long. Okay, so that's a very common assessment. By the way, this time I have integers. When I have these kind of integers, let's watch out for that because there's known as Pythagorean triple. Since we have these integers, like 3, 4, and 5 in this particular case. Okay, that's assessment. Now let's talk about the relevance. One of the things I like to do, if you followed any of my research, I have a 3-legged stool that I've used for one of my models. So this 3-legged stool, I'm not the best artist if you've seen my videos too, but that doesn't keep me from drawing a picture, which is a great practice for you. So the 3-legged stool is a real nice real-world example of why triangle is important. This is important because the legs are on the same geometric plane, which gives it a lot of stability. And you need at least 3 points to make a plane. Just like you need, and I'm gonna go ahead and write that down because I think that's really cool and important. So now I'm starting to get excited, you know, this math, it makes it so fun. So you need at least 2 points to make a line. At least 2, okay? You need at least 3 points to make a plane. And because of that, you get a lot of stability from that 3-legged stool. The other thing is that there's the legs are angled slightly outward, so angled outward. And because of that, you're creating friction in opposite directions, or opposing directions. And that also brings the stability of the 3-legged stool. So again, you see the very important relevance of this triangle that is formed with the 3-legged stool. So, okay, quick recap. And while we're doing this, remember to like this video. Subscribe so you can get other videos that will help you in your math classes, and also make sure you sign up for notifications. Okay, so again, this is geometry, star review, using the STAR model, which is subject, terminology, assessment, and relevance. Week 1, triangles. Look forward to seeing you in future videos. All right, take care. Good luck studying.